Dear everyone, this is a festive moment where we can call this conference we have prepared for a long time already open, and there is a sacred triangulum, or is it triangulus of DHNB. I should play. I don't know the story behind it, but that's how folklore is born. So I'm so happy to see every one of you with whom I have been corresponding for months and calling your papers and managing all of this now finally in person. I'm peeping all those badges and see who is who. And I would like to introduce our organizing team. Institutions. There are 5 institutions who are gathered together to organize this conference, and the organizers, could you please stand up like organizing team so we can see you. And there is Agnes upstairs, and And we also have supporters we have to advertise. Those are Cultural Endowment of Estonia and Visit Estonia with the Estonian enterprise, yes, who have granted some funding to support this conference. And nothing else. I wish you a good mood for your presentations, and I wish you fruitful discussions during coffee breaks and other social events. And I will give a word to Pille Runnel, who is representing the local institution here, and says some welcoming word before we can start with the real conference.
Yes, good morning and welcome. My role in this museum is head of the research department. So as a research director, this is also me who welcomes you on behalf of the institution, because our director is about to leave and is not in Tartu today. So we will have a change of. But on behalf of the museum board, I firstly say a formal welcome, and then I switch to this colleagues mode. So dear colleagues, I'm also really happy to see you here all. We welcome different kind of international conferences, and this venue also sometimes organizes or host conferences as a kind of rental events. But you being here welcomed by our team is a clear chance or clear sign that we have something to do with digital humanities, even though you haven't seen our colleagues in your events. And I don't probably know most of you apart from local team and some Swedish colleagues. But the kind of, it is inevitable that museums and archives and so on are linked to digital humanities, and a brief pathway to having this conference here maybe started for me 2.5 years ago, when we were meeting with our senior researchers for some kind of evaluation plan, planning evaluation stage and talking about future. And I remember myself telling them that we won't have a digital humanities group, and digital humanities will be not part of our strategy. And while kind of calming them down that the traditional ethnology roles are not disappearing, actually I realized that I'm also really wrong, because digital humanities have been slowly part of us, whether it is just about talking about museum information systems, or hearing my colleagues asking increasingly questions which could be actually addressed by digital humanities. So despite we don't do computational methods or we collaborate data scientists and kind of negotiate with them rather than form clear teams, it is coming in. And now 2.5 years later, hosting you here this morning, I was actually helping to review our submission for knowledge transfer project from research and development to museums and public sector. And why? It is because we need several projects and the results to kind of be wrapped up and merged into services and know-hows and so on to help memory institutions. And these all have to do with digital and digital heritage. So, oh boy, was I wrong only 2.5 years ago. So this is why I'm really, really happy about this event here, in terms that I hope that we as a museum and also as a research institution can bring something to you. But you being here certainly is a kind of step of advancing our actually kind of tasks and obligations in this field, because I think digital humanities is not a kind of side topic or side field or field bringing only you together, that it is kind of inevitable and very necessary part. So I have enjoyed past 2 days with the workshops, but now I look really forward to these 3 days of conference. And thank you once more, and I will give the floor to the next speaker, who will be a moderator of our keynote. So Joshua, the floor is yours.
Hello, hello. Good morning. My name is Joshua Wilbur. I'm lecturer in digital linguistics at the Institute for Estonian and General Linguistics in Tartu at the University of Tartu, and I have the honor today of introducing Maciej Eder, our first plenary speaker, and moderating this first talk. So let me start with his current job. Maciej is director of the Institute of Polish Languages at the Polish Academy of Sciences. And he actually has a new job, but I'll get back to that. He has a PhD in 17th century Polish and Latin literature from the University of Wrocław. He has a habilitation in linguistics, which led him to being appointed professor in literature at the Pedagogical University in Krakow. He's a principal investigator of the Horizon 2020 project, Computational Literacy Studies Infrastructure, a big infrastructure project that a lot of you, I'm sure, have used. It's a great resource on high-quality digital data, tools, and knowledge to support digital approaches in literary studies. He also created a very popular R package called Stylo. If you've done any stylometry using R, the chances are probably pretty good that you used Maciej's package. And if he's an expert in computer-assisted text analyses, including neural network technologies and large language models. So, I mean, if that wasn't enough, a long enough reason or a list of reasons for him to be here today, let me come back to his new job. Another reason that he's here. So at my home institute, which, as I just mentioned, is the Institute for Estonian and General Linguistics here at the University of Tartu, we just received some Horizon Europe funding in the ERA chair scheme. So this just started literally this month, so Monday was our first official day of work. And it's establishing what we're calling the Center for Digital Text Scholarship. Digital Text Scholarship shortens nicely to DIGITS. So we're calling this project the DIGITS project. And the ERA chair funding, among other things, supporting digital humanities here at the University of Tartu includes supporting a new professorship. And this is Maciej's new job, in addition to his other one, at least for now. So Maciej is our area chair here at in the Digits project. So he just started. He's my newest colleague, in fact, at our institute. So he's area chair holder and visiting professor at the Institute for Estonian and General Linguistics at the University of Tartu now. We're just working on getting his email set up. It's taken several days, but we'll get there. Hopefully progress will continue at a bit faster pace after that. A little bit about the center. The point of the Digits Center is we're putting together a research center under Maciej's leadership for cutting edge methodology in computer assisted text analysis. We're talking about NLP for under-resourced data sets, text mining of large text collections, using topic modeling, for example, and LLMs to analyze larger text and smaller text sets. Any sort of comparative analyses of text. In this context, we're also hiring we have 3 postdoc positions and 2 PhD positions that will be announced in the coming months, hopefully sooner than later. So if anyone's looking for a job and you are impressed, not maybe by the weather, because the weather today is really awful, but it makes the nice days that much nicer. But Tartu is actually a great place to live. I've been here for 6 years and I don't really plan to leave. So keep your eyes open if you're looking for a job. From talking to Maciej and what I know about him, he's very agnostic, I think, in this new center that we're setting up. So if you have ideas for a project, bring your own expertise, and we want to create an important and interesting and valuable center here in Tartu. Okay, one final thing that I want to mention that I read when I was looking at Maciej's on his website. He mentioned that he thinks in Polish, he codes in R, and he tweets in English. So today we get to find out how he presents his keynote addresses. I know some of you probably prefer R. I'm hoping it's in English or some other language I understand, but yes, now we have the chance to find out. So let's welcome Maciej.
Thank you very much, Josh. That was an amazing introduction. Thanks a lot for that. And yes, it did. This is the 3rd day of my new job here in Tartu. So I hope this is going to develop in a good direction. In a conference batch, we've got this, descriptors, the country we're from. I've got Poland, but if it was Estonia, it would be also kind of a good descriptor from Monday onwards. So my today's talk is going to be about some general issues in text analysis. I'm sure that some of you, maybe many of you, will find it very introductory, but I was also thinking of the other part of the audience for whom this is maybe a new topic, so I will try to balance it out so that I don't go too much into details, but at the same time, if you feel bored, then just blink twice. I will be very happy to go into some more mathematical details, so maybe not even mathematical, but just conceptual details. For those of you who are sitting in the back rows and want to follow the slides, but maybe forgot their glasses at the hotel, here are the slides that you can find online. They will be staying there. These are just GitHub presentations, so you can consult them at any moment. So as said, maybe just for you to write it down. As said, I'll be talking about text analysis on different levels, but before we go there, I want to make a general statement about the special situation we are now facing. I think we kind of do. And I will start with the 17th century thinker, Blaise Pascal, philosopher, also the person who introduced the first analog computer, to be honest. So he is the father of what we are doing as well. And he was writing down his thoughts throughout his life, and posthumously it was edited, and then we can consult those thoughts as a monolithic work, even if it was not originally. And one of his thoughts describes his thought experiment. He takes us on a journey, and he says, let's imagine that our imagination does not stop. Let's imagine that the whole Earth is as small as, say, the orange, but our imagination does not stop. Let's then imagine that our galaxy is as small as a ball. But our imagination does not stop. Whatever we do, we can, in our imagination, we can go further and further and further, and it will never stop because there is infinity out there. There is no limit, right? Our imagination has no limit of going outside the universe. And then when we go back, of course, he says we get scared how small we are. But then he proposes to take us on another journey into the inside our body. And again, he says, let's imagine that our blood cells are as big as Tartu. But our imagination does not stop. So let's then imagine that each particle of each cell is as big as Estonia. But the imagination does not stop. And again, there is no limit. So he comes to a conclusion in this thought experiment that we are seeing two, we don't see them, but there are two infinities. And, a human being is somewhere in between, like between nothing and everything. And this no limits was a foundation, one of the foundation of the scientific revolution. That's the guy, that's Blaise Pascal, of the scientific revolution that we are seeing in the 17th century, which was possible because of several things happening roughly at the same time. Excuse me. It was the instruments, the introduction of the telescope back in the 16th century and the microscope at the beginning of the 17th century. That's one thing, so the tools. The other thing was the theories, the theoretical frameworks. Blaise Pascal was just one of those, right? Of those thinkers. There were many of those that led to a scientific revolution in the 17th century, which revolutionized everything in the hard sciences, in the earth science, in the life sciences. And I would argue that we are seeing quite the same landscape right now in the humanities. That we've got these new tools. This is the computer power to start with. It can be dispersed. It doesn't have to be a desktop computer. We've got the internet, and we've got the resources on an unprecedented scale. This is research infrastructures I will be talking about in a minute, but this is also data sets. This is also the corpora, the millions of books already digitized, the millions of books enriched with some technology, with grammatical layers, and so on and so forth. We are seeing now on an unprecedented scale the growth of the computer power, the resources, the theoretical framework that is also there. I call it all infrastructures, but I will cover it in a minute. So I would argue that this is the right moment. Actually, it does not happen today. It started happening 15 or so years ago. But what is 15 years in the human's history, right? So this 15 years that we are experiencing now, that's the big moment in history for the humanities. And I would argue that we are seeing the same kind of change or self-development and as the sciences saw in the 17th century. I hope for the best. I'm absolutely sure it will lead to some major discoveries, but we'll see. There are 200 people sitting in this room, 200 great brains. So that's our job to push it forward. So with this said, these new disciplines that are emerging, I find them so interesting. Some of, including the sub-disciplines such as text analysis, stylometry, and NLP, some other technologies going under the umbrella of digital humanities. I find it so fascinating exactly because there's a melting pot of different ideas that are being, like boiling, and we don't know what will come out of that. But it wouldn't have been possible without the infrastructures, those resources I was talking about. And now I would like to devote like 2 or 3 minutes to praise and to make an homage to the infrastructures, because everyone, myself included, maybe particularly myself, we would love to just do research, to do science, to do the discoveries, to publish in those prestigious journals the final discoveries. Using the metaphor of climbing the Mount Everest, everyone would love to be the one to do the summit attack, right? However, it is not possible without the infrastructure, without plenty of people working for that final team to to attack the summit. And these are these infrastructures, the research infrastructures. One of those being the project CLS Infra that Josh has covered a minute ago, the project that has concluded we got an extension for another half a year, but basically all the deliverables, all the work has been done already. This is one of the examples. The other examples is the Clarion project, the Daria project. There's plenty of those. CLS Infra is specifically designed to provide infrastructure for computation literary studies, so text analysis and some other adjacent fields. And as we define infrastructures, this is not just the toys. As you might think, the nuclear physics people, for them, the infrastructure is basically those big colliders, right? Hadron colliders, or the big toys. For us, the humanists, this is not only that. This is the network of people. This is the resources themselves, I mean the digitized books, but this is also the tools to enhance those digitized books with the grammatical layers, structural annotation, XML structure, and so on and so forth. This is the theoretical framework. This is many different angles from each which have to be met in order to build an infrastructure. And the CLS Infra project was hoping to contribute to that infrastructure landscape. And one of the outcomes of the project, it's not the CLS Infra's outcome, but we just kind of embraced it. It was produced by the Cost Action Project Distant Reading. It's a corpus of more than 1,000 full-sized novels in several languages, like 10 plus languages, that you can just grab, you can download. It's OCR'd, is corrected, is very high quality, is XMLized, it's TI compliant, it's balanced in terms of the male authors, female authors, the number of novels per each author, long novels, short novellas. So of course, the balance could not be kept across all the languages and across all the literary traditions for many different also historical reasons. But still, you can just get it. It's a very, very high quality corpus comprising of more than 1,000 full-sized novels, just for everyone to do analysis on. Another example, which is again a part of the CLS Infra project, is Dracor. Dracor is not really a corpus. It's a hub for corpora, for drama corpora. Now they've got like thousands of full-size dramas with very, very fine-grained structure, XML annotation, grammatical annotation, everything you might wish. What is absolutely fantastic about this project is that it's a hub for your corpora. So whenever you've got a corpus of Estonian drama, or corpus of Swedish drama, or whatever else it is, you may just make it compliant with their requirements, and then they will be happy to just put it as a part of their infrastructure, which still, while still keeping your rights to change it, to maybe even withdraw it, it's still your corpus. You're an owner of that. You can do whatever you want with that corpus, but it's compliant with all the other corpora in this big collection, which also allows the users or the researchers to say, grab 10 corpora and to do some cross-language study on whatever you might want to. We did a study, that's a digression, we did a study using this corpus on how distinctive are characters by different playwriters. So we compared how distinct are the characters from Shakespeare, from the French drama, from Russian drama, from something else, and we came to some conclusions. So you can grab those corpora and just do your stuff as much as you want. Yet another outcome of this project is, I mentioned this theoretical framework as one of the very big factors here. That's, you might want to say, a book. It's not a book in a proper sense. We just decided to make it a grid of chapters. So each of those, it's a website that you can find very, very easily. It's a website, and this is a book organized in the form of a grid, so we can read it either vertically. So, for example, the left-hand column is about a general introduction to corpora building, pre-processing, data analysis, and evaluation. You can read just that column. You might, however, be interested in, say, canonicity, literary canonicity. Then you read the far right column, right? From corpus building, pre-processing, data analysis, and evaluation. But you can also read it horizontally if you're just interested in different ways of evaluation, of different ways of corpus building. Or you can read it just from A to Z if you like. So that's our new form of putting the stuff, hoping that this kind of textbook will be useful in text analysis. Okay, I'm mentioning text analysis all the time, so it's maybe a good moment to start going into the bread and butter of my today's talk, and to say something about what I really mean by text analysis. And there's many different things you can link to the name of text analysis, but if you wanted to make a major division, there are two different approaches, roughly speaking. Of course, there are more, but two main approaches. One is you might want to grab your big text collection, say a library or something, and you might quickly read through all those documents to get the knowledge what those texts are about, right? Because we, the humans, are not fast enough to read all the books from the library within hours. So there are tools like topic modeling, like keywords analysis, like many other tools like that to read those collections for you, or to maybe do some clustering, to cluster all the books about Shakespeare together, all the books that are saying bad words about Shakespeare together. You name it. That's, depending on your research question, you might cluster the books you find in this or in that way. That's the approach number one, so content-centric. You might want to just do the information extraction analysis. You might want to be interested in what those books are about. And the second approach I'll be focusing on today, that's the approach at how these books are created, what makes them different. What are the stylistic or other differences that make a book A and a book, or a text A and a text B different? So this approach might want to use statistical inference to detect, well, the statisticians say signals. This is, something that make them different. To extract the features, the language features that make those texts different. And this is what I'm going to focus on today. So the theoretical foundations of this kind of approach, I already mentioned some of them, but I think there is a good moment to focus on them right now. This is first and foremost a legendary John Burroughs and his even more legendary book, 1980-something, 87, on Jane Austen's novels, in which book he introduced the concept of computation into criticism. And the assumption was as follows. He said, hey, in literary scholarship, literary criticism is the most subjective field, or the most subjective way of inferring or doing the interpretation. What if we enhance these procedures with some exact methodologies? What if we combine the exact methodologies with a literary criticism? What about, he says, doing this computation into criticism approach? And it turned out to be quite revolutionary, because from then on, more and more approaches applying exact methodologies were conducted with great results. Then came algorithmic criticism, was just a different name by Steve Ramsey, added to or proposed to the same way of thinking of doing literary criticism with the help of technology or statistical inference. Quite a revolutionary was distant reading as a notion introduced by Franco Moretti. Probably there is no single person in this room that haven't heard about Franco Moretti and distant reading, but there's probably not too many people to remember that the original notion was slightly different than we think it was. And the original notion was, let's not look at the books themselves. Let's not even open them. Let's not read the text as they are. Let's instead focus on metadata alone. So let's just grab the titles, let's grab the year of publication, the author's name, all these metadata. And then if we collect hundreds of those, then we'll be, without any reading, we'll be able to observe how, say, Bildungsroman evolves into, say, post-romanticism or something like that. This kind of traces we'll be able to observe, he says. So distant reading was originally an idea of not even looking at the novels themselves. So that's the reason why for some time he was referred to as an enfant terrible of literary criticism, because he said, no books, just give me your title pages in a massive amounts, then I will be able to say something about literature, using this bird's eye approach, this view from above. So that was the original distant reading notion that was then filled with some other meaning by, among others, Matt Jokers, who published this very seminal book, Macroanalysis, in which he basically does distant reading, but this time he goes into the books themselves rather than just reading the metadata. So he's doing topic modeling and some other approaches of that kind. It was 10 years ago. Still, that's a fresh book in many respects. He's doing data analysis on a big scale, or on a scale that was then perceived to be big, like 4,000 books, English novels at a time. And what I want to stress is that not all of those approaches are focusing on the text themselves, on the books themselves. There are some other approaches that look at the readers instead. And here I want to mention the project Riddle of Literary Quality from Amsterdam, the Netherlands, led by Corinna van Dalen-Oskam, who is trying to find correlations between how the books themselves are written, so the textual features, and how the readers rate those books. So she ran a survey, a big survey, like 20,000 plus people responded, rating the books. Is it literary, not so literary, very literary, on a scale from 1 to 7, how literary it is, and how good it is, from very bad to very good. And they found a very strong correlation between the quality and the literariness. So people who consider a given book to be very literary, they usually consider it to be very good. There is a strong correlation, not a one-to-one, of course, relation, but a very strong correlation. And what they find was that very non-literary and the very bad book was the 50 Shades of Grey on the one poll. I don't remember what was on the other poll. I find it quite funny. And then they tried to find, in the text themselves, which topics are more likely to appear in those less literary novels and more literary novels? Which other language features are more likely to appear in those books? So they were trying to use this macroanalysis methodology in order to find which textual features are responsible for making a given book good or bad or literary or not so literary, right? So not only is it just looking at the text, but also sometimes looking outside the text on how the readers feel about those texts. And why this text analysis can be, or for which applications it can be used. My personal field is probably authorship attribution at the first place. I like it for many different reasons, no time to cover them all right now, but this is also forensic linguistics and, pinpointing some bad guys for what they wrote and putting them behind bars. That's another application, but also something which is important for the linguist, which is register analysis, to answer what makes formal English, for example, different from informal English. What are the features actually? Of course, on the surface, we can observe some features, but if you massively analyze the corpora, the question is, what are the actual features, language features, grammatical features, for example, that distinguish formal and informal language, business English, general English, things like that. Genre recognition, what makes, poetry and prose different, for example? A very simple question for a human, but the question is, can we pinpoint the actual features? Gender differences. That's a difficult topic if we stick to this binary model of just male and female literature. But if we allow for some non-binarities, then interesting patterns can be observed, and actually has been observed in several studies. Translatorial signals. Believe me or not, but if you take translations of a given literature into another language, say, take a random selection of novels in English, translate it into French, and then you will see in this French corpus still the original traces of the authors, of the English authors, even if they didn't, know French at all. So that's an interesting thing to observe, this translatorial signal. Also, the problem of mature style. Do we develop our style over time? That's an interesting question for some people, and so on and so forth. Also, some linguists try to ask the question: can we detect dementia in the way you're writing, or early signs of Alzheimer's, for example? Or can we detect depression? Can we detect hate speech? That's a big topic, of course, right? So these are the applications of text analysis. These are plenty, ranging from these linguistic applications all the way to very, very literary ones. Now, let's move on to some actual research question. It's not a real one. It's a random selection of two texts, and the question for a human being, what makes them different, might be rather simple to solve, right? Because we see some, line divisions. We can see if we take a closer look, we see some vocabulary that is slightly different in the 17th century poem by whoever. I forgot the name. Of course, the big 17th century English writer. Thank you very much, Milton, of course. And the beginning of the 19th century novel, we can discover, some lexical patterns very easily. But the question is, what if we just go beyond these very surface patterns? What if we go beyond some obvious lexical similarities? And then we discover later in textual analysis, people love very much frequencies of different things, just comparing frequencies of words. How does a word, say, home, how big is the difference of the word home in the text A, and how big is the difference of how big is the frequency of the same word in the text B, for example, right? But not only that, some people are measuring. Back to that slide. Some people are measuring the rhymes, for example, or some other syllabic structures, or some alliterations. So it does not necessarily need to be the frequencies of words. You can think of any other features, textual features, for example, grammatical features. How big is the proportion of adjectives in a text A in comparison to a text B, right? How big is the proportion of, say, subordinate clauses in a certain group of texts? So these features, there's an infinite number of features you might want to use. In my talk today, for the sake of simplicity, I'll be focusing on the frequencies of words, but please remember that this is just a tip of an iceberg. The same goes for the methods of measuring those differences. There's plenty of those. Josh has mentioned large language models, or language models in general, as a very nice way of finding those differences. Neural networks, generally speaking, very, very solid way of detecting those differences. I'll be today, however, focusing on a very, very basic level of comparison, which is the so-called distance-based methods. If you want to hear more about other methods, I'm here. I'm not going anywhere, so I'll be happy to take the questions. But just for your knowledge, for your interest, I will be just staying on this tip of an iceberg today. So this is, in a way, the most important slide I'm to show you today, because we, the humans, we, the digital humanists, tend to forget how important are representations. And this is a representation that one of those that we are using every time, any time and every day. So this is a text. It is a truth universally acknowledged, and so on and so on. This is a text of a novel, but be it any text. So what we do here, we just move through this text and we count all the instances of the word it, all the instances of the word is, a, truth, universally. We just count them. How many of those are in the text? Then we might normalize them by dividing by the total length of the text. Whatever you like might be applied, but the general idea is still the same. We turn them into representations. So here we can say that this text is represented by the mathematicians would say vector. We can say a column of just word frequencies, the two of with their frequencies. Now, why I think this is super important to stress? Because we tend to forget, or maybe I take another path. There is a criticism that in text analysis, in digital humanities, generally speaking, hey, what you do, this is reductionism. Because look at this literature, look at the Ulysses by James Joyce, how complex the structure of that book is, how complex is the structure of characters, the plot, the narrative, patterns, all those things, and you are killing them all, right? This is reductionism, they say. And I say, well, it's even worse. Not only that, because not only we kill the narrative structure and the characters, we also kill the linearity of the language. We don't even keep, the words in their original order. We just count them, right? So whatever kind of representation, all the LLMs, all the neural networks, all the other machine learning approaches, they are based on representations, on this kind of a column of values, right? So your beautiful artifact, literary artifact or physical artifact or a photo, whatever, is being reduced to just a vector or a column of numbers. Is it reductionism? Well, yes, it is. At the same time, we are losing 99% of information, but this 1% that we're keeping, we can tell quite a lot of things about that 1%. And that's what makes, in my eyes, that's what makes the digital humanities approaches so interesting, that we just reduce vast majority of the information. We focus only on this 1% that we can measure, but we do it well, right? So that's the reason why still this is reductionist, but in a good way, right? We still hope to get some knowledge out of it. So representations, that's the starting point for doing whatever we want. For example, text analysis, comparison. So these representations here are ordered. So we've got particular books. Here, these are not in columns, but in rows. So, say, The Lion by C.S. Lewis is represented by this, row of word frequencies. That's a representation. That's something that we put into the machine learning system, right? As simple as that, except that this is not that simple. Before I go to some results, let me tell the background story, because that might be interesting for some of us. Back in time, like 5 years ago, a person, Galbraith, oops, sorry, I don't want to show you that yet. Mr. Galbraith published a book, Cuckoo's Calling, somewhere in Edinburgh, Great Britain. And the person sold like 1,000 copies, not a very success it was. And then a rumor surfaced that this Galbraith might be in fact J.K. Rowling, using a pseudonym. And a colleague of mine did this study, that's not my study, that's his study, in which he just put a couple of books by Coban, C.S. Lewis, Tolkien, and Rowling, of course, and here's this Galbraith with Cuckoo's Calling. And she was shown this picture doing an interview, and then in Christ she confessed, yeah, I have to say that was myself. And then the scale, the sales rate skyrocketed, and she sold like millions of books, of copies of that Cuckoo's Calling, which also tells you that something about the dynamics of the market and of the name. She was just doing an experiment, how feasible it is to be a no-name and still be a successful writer, seemingly not so much, right? So that's what text analysis can be used for. But I'm showing this picture specifically to show where's the destination, right? What we are hoping to get. This kind of picture plot, we the humans love plots and colorful pictures, on which we can guess what is more similar to what, and then we can generalize on top of that. I will say a few words about software, but not go into details. As Josh said, I myself wrote one of those, this package Stylo, that I will be saying more about in a minute. It started as a private project. I just wanted to do some text analysis comparison, and a friend of mine from a different department say, hey, I can use it with my student, but please add this and that functionality. So I did, and then we together added the graphical user interface, and it proved to be useful. So that's the background story. It's not a very serious piece of software, but it has become quite used in the world. But there's plenty of software solutions out there. If you really look around, within 5 minutes, you will find 10, if not 20, very fully fledged tools to do text analysis comparisons. So this is not the problem of a tool. Today, we've got the tools. It's just the problem of using them, and I will be talking about that more. So the Stylo package for text analysis, as said, it was a side project written in the R language that not too many people were using back then, but I wanted to get rid of any paid or proprietary software, so I started doing it from scratch. These days, or today, I would have done it in Python probably, as most people choose, but 10 years ago, R was an obvious choice. So it's a simple and very fast tool to do text analysis, the downside of which is that you have to type your code, right? It's scary for some humans, I know, I get the point, but at the same time, it's a relief for the Python users or the R users that finally they can type their code. However, this code is not very substantial. This is just 3 lines of code that you need to type. 3 lines of code, and this is all text analysis skills that you need to have in order to run one of those tools. As for the other tools, some GenSim requires you some coding, but some other tools I mentioned a minute ago, they don't even require that. So today, text analysis is really easy. You just click a couple of buttons. If you run Stylo, then you don't have to mess with the parameters. You just check them using this graphical user interface. Then you check some other parameters, click an OK button, and and you're good. However, and that's the topic of my today's speech, the question is, which of the parameters should we pick? And why this rather than that? That's a very fundamental question, and the answer is not easy at all, and if there's a definite answer, at all. So that's one of the final representation. This is referred to as a dendrogram, or a tree-like structure in which we see some clusters, so we can guess that some authors, some texts, some literary traditions tend to cluster together, some other don't. That's one of the representations. Another is the multidimensional scaling. A different mathematical model is behind, but the general idea is very much the same. In this plane, you just want to identify which texts are closer one to another. And then, depending on how you define the closeness, that's a whole different story. Here you can see this Galbraith person being very close to other books by J.K. Rowling, if you're into that question. Wait a sec. Here is C.S. Lewis and Tolkien, the 2 guys that were very close friends in Oxford. They were meeting every night for beer and discussing the things, but then during the days they were independently writing their stuff. And when interviewed, each of them would say, no, I'm not inspired by Tolkien whatsoever. No, he's my friend, of course, but no connection. And the same for Tolkien. So, no, C.S. Lewis, my good friend, maybe best friend ever, but no inspiration here. As we can see, well, I don't know, right? They might have been somewhat inspired, but that's a different question. That's a different method, but still you can produce it using Stylo. The method that expresses not only the strongest connection, which is the authorship, but come on, we know that Shakespeare wrote Hamlet. This is not the most important question of the world, who wrote what, right? Maybe a more important one, more interesting one would be, well, we've got Conrad. We've got Conrad, and who is the next similar author to Conrad? That might be the question. As you can see in this picture, we've got a very nice progression from the late 18th century all the way through the Victorians to the beginning of the modernism and the beginning of the 20th century. So there is this progression, chronological or temporal signal that is embedded in this picture. What else we can see is the Bronte sisters recognized by the machine to be very similar one to another. Is it because they were brought up in the same room, they had the same teacher, they read the same books, and the Charlotte was proofreading the books of the other two sisters? Maybe, we don't know. But that's an interesting trace of similarity between them. And what is particularly interesting for myself is Joseph Conrad, and that's the Almayer's Folly. Of course, we know the book was written by Conrad, but it was the first book he ever wrote in English. He was Polish, then he got drafted to the French Navy, so his second language was French. Then he switched to the Royal Navy, so his third language was English. And then he started writing English, so he was not confident enough about not being, idiomatic enough in English. And his debut is the Almayer's Folly. And the next neighbor is Galsworthy. And guess what? This is the author, Galsworthy, best friend by young Joseph Conrad, who was consulted very heavily when Joseph Conrad was compiling or finishing his book, The Almayer's Folly. So there are some traces of this friendship in the way in which they write. Okay. Let's move on. Stylus extensions, so not only just comparing lots of books at the moment, but some other questions can be addressed as well. For example, if you want to trace some distinctive words, like keywords, representing one group of texts as opposed to the other group. And now, before I move on and show you the next slide, that one, a disclaimer. Some of you might feel offended that this is not my intention. Namely, as a just toy example, I took a bunch of books written by male authors and a bunch of books written by female authors in the beginning of the 19th century, English authors, they or are. And I did a very, very simple keywords analysis comparison. And the results were shockingly stereotypical. That's the results. No intention to offend anyone. So the female words like feelings, glance, post, feeling, smile, whereas the male 1,000 bottle, wig, honor, this kind of vocabulary, right? I know it might sound, not appropriate, but to me, the interpretation is important here. To me, it seems that the social pressure was so big that the female author was simply expected to write in a certain way and use a certain vocabulary and address their books to a certain audience. So that's probably the expectation of the society rather than, a genetic difference between, those two genders. I don't want to go too far with that because those results are kind of disappointing, at the same time quite telling, are they not, right? So this is one of the extensions of the Stylo package. You can for example, contrast the vocabulary of the words said by Romeo and Juliet and see who says what and which words are most distinctive for the two of them, for example. Or once with the students we did the debate Hillary Clinton versus Donald Trump, and the words were very interesting, to find the words. So these kind of questions can be addressed using that extension. Another extension is the sequential analysis. So far, I've been treating each text as an entity, as a unified monolithic entity. But what if we've got a rather long text, such as the Bible, for example, that might have some interesting changes in stylistics changing over the course of the development of the story, right? So what if we apply this methodology in a sequential way? So here's an example. And the example is the French 13th century allegoric poem, Roman de la Rose, which is about a young person, a boy or a young person who wants to pick up the rose. Of course, we can read the symbol of the rose and picking the rose, and the rose says to him, wait a sec, you don't deserve it yet. You have to go through education, and only then I will let you pick myself, right? So that's a story about the development of this person and becoming deserving this rose to pick her, right? So this is a education in the direction of the courtesy love and this kind of things. And we know that it was written, the first part by Guillaume de Laurier, who then died, and it was then taken over by another author, Jean Demain, some years later, and he was honest enough to admit somewhere in the middle of his part, hey, by the way, I took over from my deceased friend, Guillaume de Laurier, and his last words were this and that. And we've got the very, very line, which was the split of the authors. So we've got a great playground to test the methodology, because we know what to expect. And now we just want to see if the computer also sees the switch between the two authors. And here we are. This is the text. This is the Roman de la Rose. That's the switch that we know should exist. And the colors are the authors suggested by the machine. So as you can see, the method detected it very, very well, right? That's the very, very takeover point that we expected, that we expect to be seeing. But what I was surprised to see was some other segments, like those green parts in here, as if the second author just adjusted the first story so that it goes well with the continuation. So maybe he just wrote those segments. We don't know. We have no proof. And same goes for those segments. Maybe these are the segments from the original part, just transplanted some, miles away to fit the whole story. We don't know, but that's something to start the conversation on. That's the stylometric on the go, on the roll, or rolling stylometry, to see particular fragments of the books, how they develop. Now, with this all set, it's been good news so far, and now it's a moment of bitter truth that it's really easy to click the button and to get the results. But it might be too easy at times, because there is quite a lot of, blurriness in the data. And that's actually the topic of my talk today, but I just wanted to squeeze it into 5, maybe 10 minutes, I want to send a positive message rather than to scare you out from doing text analysis, right? But I just want to make this critical remarks, or some bitter remarks along the line. So these methodologies that are very much reachable today, it's just out of the shelf tools that you take, that you click the button, you throw some text in, and you get a beautiful picture out. This is very tempting to produce your output and go to the publishers and say, hey, this is my revolutionary results. And the problem is that I know that in this room there are not only the humanists, so I'm saying mostly for myself. We, the humanists, we have a tendency to worship the statistical methodologies and the numbers, right? If there is a mathematical equation, we say, wow, it must, be telling the truth. That's our bias, let's be honest. On the other side, these are the computer people who are also biased, and they tend to underestimate how wobbly the language is, how not precise the language features are. And the computer scientists, they have this tendency of falling into the fallacy of chasing the accuracy. So in my paper, I'm showing that I get 96% accuracy, which is better than your 95% accuracy. That's their bias, right? So we all have some biases that we bring into the table. So the point I'm going to make is that we should be aware of those biases, and not only that, we should be aware that the data set that we deal with, it already contains all those biases and uncertainties. So let me go back to this most important slide of my talk. So that's another reason for showing it you today. You've seen it already. So let's focus again on these frequencies. Maybe let's focus on just the first frequencies. So we've got the frequency of the word the. We go through the text, whatever it is, this text might be. We go through the text, we count all the instances of the word the, then we divide it by the total number of words, and we've got the frequency. So we've got the frequency of 3 3.52. That's the frequency of the word D. Now, what about doing an experiment? It's not a thought experiment. It's a very simple experiment with the data. I just slice this novel into 1,000 word chunks, and then I observe the frequency of the word D in each of the chunks. So that's what I did. So the mean frequency is, of course, still 3.52, but then in those particular chunks, well, it depends, right? It could go as high as to 6.1 or as low as to 1.2. Quite a wobbly situation, quite a blurry situation, isn't it, right? So that's a problem that we tacitly assume does not exist, whereas in fact, this wobbliness is everywhere in the data. So if we take the arithmetic average, then of course, arithmetic average of all those values will be the final 3.52. So there is a reason of using this frequency over any other frequencies. Of course, I get the point. But still, there's quite a lot of blurriness in the dataset. We cannot expect an artist, Jane Austen or whoever, to write precisely with a frequency of 3.52 in every single segment. We cannot, expect a photographer to be exactly, in this hue of blue as, seems to fit the model. We cannot expect the humans to be exactly behaving like a model would predict, right? So if we just count those segments, so that's the segments with very low frequency of the word Z. That's the segments of the 6% of the Z, only one of such segments. But for most part, we'll be seeing something around this 352, right? Some of you might be familiar with this kind of representation, which is a distribution, Gaussian distribution to be precise. And here is an arithmetic mean. So there is a reason, of course, to use this arithmetic mean as our proxy. However, this is still a proxy, and that's my point, right? So we are using those frequencies. We are using those mean frequencies for a good reason, but still we tend to forget that these are proxies, only a proxies. And now we are just doing one word. Think of all the other words, think of other features, think of a situation when the author of this book, say Jane Austen, was hangover or something when writing the last chapter, and the frequency is different, not hangover, but maybe having whatever, right? Whatever the reason was. I don't want to suggest that she had a reason to be. Sorry for that stupid comment. The point I was making was that we are not robots, right? That sometimes we've got a better day, sometimes we've got a worse day, and we cannot expect that each text we have on our table, this is the final polished product, right? The text that we have on our table, this is has some alternations introduced by the editors, by the textual tradition, all the corrupted manuscripts, whatever it is, right? The text that we are dealing with might not be 100% representation of what the author wanted to say or intended to say, whatever, right? So wobbliness everywhere. That's my message. Now, a very simple. Again, simulation, that's a simulation. If I just compare the text of Jane Austen and the Bronte sisters, taking one text as one entity, that's the picture. We've got 4 distinct clusters, looks okay. But then if I divide them all into 1,000 word chunks, then the chunks are less. They start to overlap, right? So they are less clear-cut. So that's my point, that in fact the data set is less clear-cut that our final picture might be suggesting. That's the point, right? And to make it even more scary, we are just doing one simple analysis. And now the question is, should we get the frequencies of 100 most frequent words or maybe 1,000 frequent words, which is better? Or maybe we should do some other representation. Maybe you should take syllables instead, right? And if I do many of those comparisons with different features, I will see that the differences are there in the results. So which results are better? And that's the big risk I'm going to make you aware of. And this is the risk of the so-called cherry picking, right? So that you just go through the results and you just pick the one that that goes well with your initial hypothesis. This is not the way to go. But we need to be aware that this wobbliness is also visible through the fact that if we tweak the parameters, the results might be slightly different. Does it mean that digital humanities technologies are just to be thrown away and forgotten forever? No, I don't think so. It just suggests that if we still see some wobbliness whenever tweaking the parameters, it might suggest that the data is not as stable as we thought it was. So the same goes for all the other parameters that are to be set. In topic modeling, there's plenty of parameters that are set as default settings, but you might tweak them. There is a reason for doing so, right? And if you tweak them, then the final results are slightly different. And the good question is, to which extent we are allowed to tweak with these parameters? My provisional answer is that the data is kind of wobbly, so we have the right to be wobbly back and to tweak with the parameters to see to which extent it is getting stable, right? So my idea is to introduce some controlled earthquake to the data and to see which parts are going to be stable and which are accidental. That's my solution here. So my overall message is, there is a good news after all, but we just need to be careful about the experiments we are doing. So there are some methods, the one you've seen already, that compares many different features and then tries to build a overall picture. That's the one. Not very informative, though. Or something like randomly picking a number of features. So here you've got this table we are already familiar with, and the idea is to do it in 100 runs or 1,000 runs or 100,000 runs, whatever. And then in each run, you just randomly pick like half of those features, randomly, totally randomly. And then you do the comparison, then you do it again and again and again and again, and then you compare it across all those iterations. That's the so-called bootstrap, right? To see to which extent the data is wobbly, to which extent it's blurry. So there are some ways of doing so. That's the so-called general imposters method that does the very thing of resampling and resampling and resampling in order to see what is accidental and what is likely to be stable in the data. So my final message is, don't despair, the hope is there, but just be more careful, right? My basic idea is, or my basic observation is that like 15 years ago, we were in the phase of collecting the data, XMLizing it, and making it usable or making it fair. Then was the second generation. I'm part of this generation, I guess, to discover that we can do some statistical inference of that. But there's the third generation. Most of representatives of that generation are sitting in this room that should say, hey, but yeah, statistical inference, okay, but let's do it the right way. Let's ask our statistical colleagues at the computer science department, because at some moment we should not just produce the first final results and run to the publishers and publish it right away, because that might introduce some damage. So that's my final message today. So use those tools, please do, but with care. That's it. Thank you very much.
Thank you very much. Yes. Now we have some time for discussion and questions. I think I saw a hand here first.
Hi there. Thank you very much, not just for a great talk, but also for your very clear enthusiasm for this, which is a big positive. Not a question, just two comments. One point that you made I found really interesting, because you might have heard of Michaela Malberg, corpus linguist, very much involved in work of Dickens and analysis. And she made a point in December, same as you, but the other way around. She said, for us corpus linguists, we looked at data, and forgot the idea of there's language with variation, etc. And now we start realizing we should have to go back and look at the philosophy of language, etc. So it's nice to hear that within a few months twice, so it's clearly a point that is being made. One other comment, when you mentioned that we, with our tools, seem to reduce language or pieces of literature, etc., to 1% and forget 99%. It's probably interesting or important to note that the average reader only takes about 12 to 20% of text, any given text. So we're not doing too badly. Thanks.
Okay, yeah, thanks so much. There's not so much to add on top of what you just said. Thank you very much for this remark. I find it like illuminating. Thank you. Thanks a lot. But going back to your first remark, that's what I love so much about the DH. This is a, there is a field, not a discipline, perhaps a field rather than a discipline, that people from different, they bring their perspectives from different disciplines, from linguistics, from computer sciences, and they do the thing that you've just mentioned, this triangulation of the points of view. That's super fantastic here in DH. That's one of the reasons I like it so much. So thank you very much.
Okay, I think here. No, there's a microphone coming.
Relatively technical question about the styloparameters. So, as you said, it's quite the key to find the right combinations. Maybe they give you some intuitively meaningful results. Do you think there might be some computational methods you can experiment with, say, the evolutionary robots generating different combinations and reinforcement learning, then give you another interface, show you 40 different kinds of possible tweaking options?
Okay, that's a cool one. Very nice a question it is. So tweaking the parameters, so the very, very short one-word answer would be cross-validation. This kind of thinking, right? So, laboratory experiment in which the final classification. So you collect a number of works written for sure by male authors and for female authors, and then you just take the labels out and you find to fine-tune the model as much as this distinction is being reproduced. The same about authors. So in authorship attribution, just take the labels out, but you are sure what the classes are about, and then you just torture your parameters as long as you refine the parameters. But the main point of your point is to like produce some new parameters or extend the parameter space by generative models, which is absolutely fascinating. We would probably need trillions of years to compute it all, this very, very dense the parameter space, but there are some methods of doing it kind of randomly. So you randomly walk around this parameter space, and then the directions that are more promising are being promoted, and then the those technologies self-improve. So yeah, absolutely, there is the direction to follow. Thanks a lot for this suggestion. But maybe one more word for the computer scientist. This is quite obvious that the cross-validation is to be used. So that's the situation when you just blind some parts of your data and you pretend you don't know the answer and you make it guess in several turns. However, again, back to the humanities world. We the humans know very well that, for example, in authorship attribution realm, that an author does not have to stick to their style once and forever. And if you take, my example would be Virginia Woolf, for example. She's so Prothean. Her style is so much different from one book to another. She's absolutely amazing. She's very difficult, if possible at all, to pinpoint stylometrically, right? So would you expect that person close her in custody, as long as she would be conforming to her own style? This is a limitation of this cross-validation approach. It assumes that each of the samples in your data set behave in a predictive way, right? So that's a limitation. But even despite this limitation, I think that the cross-validation would be the way to go.
Thank you so much. It was absolutely fascinating. As a sort of hard scientist side of this story. I wanted to dig a little bit into this technical part with the distribution of words in parts of a long text. You said that in passing that it is Gaussian. Have it been measured, studied extensively? What is exactly the distribution there?
Yeah. Once this question has been asked, it's Gaussian for the first most frequent words. For the second, it's kind of Gaussian. For the third, not so much.
Well, it should be Poissonian for real
And
words.
then it becomes very, very skewed. And Poissonian, yeah, but very, very low numbers produce very skewed distributions.
Yeah.
So that's the reason of this long tail is very non-Gaussian, very much so, yeah.
Thank you.
I have a question that sort of ties up some of the other ones. And I'm bringing one more discipline into the picture. So I'm more aware of educational sciences and how they, do similar things, but from different data. And what they are doing now is going back to sort of controlling some of the algorithmic systems from educational theories. And the first question sort of, or comment it was asking also this sort of combination of language philosophers. So how much have you been trying to see what the philosophical theories or language theories as a constraint do these parameters of data can do? So it's a sort of combining two different type of things. Thank you.
Okay, yeah, that's a cool question. So my take here is that language is a multi-layer phenomenon, and in the very bottom there are some language constraints that you cannot really break. Yes, you can, but then you will not be understood. So at the bottom there are some language constraints, some grammatical structure that you'd rather stick to, otherwise you will not be understood. On the top, however, there is an infinite freedom of the choice of vocabulary. You have no limitations, right? But in fact, if you want to write an epic poem, for example, in the style of Homer, something like that, then you are more likely to stick to some subset of this infinite vocabulary. If you are just writing as yourself, then you are probably not using this infinite vocabulary choice, or the choice of syntax structure, grammatical patterns, whatever it is. But you are probably regressing to your usual ways of saying this, right? So my take is that this authorial signal is somewhere in between those language constraints that are very, very, very sharp. And that's the reason why in grammar there's not so much signal to be visible. It is some, but not impressively much. If you transpose your input text into grammatical representations, for example, part of speech tags or some syntax trees parts, then you can measure their frequencies, but then there is not so much signal on any of those levels visible. So the grammar seems to be the anchor of language, and the vocabulary choice seems to be the part where you can see many different signals, like the gender signal, genre signals, authorial signal, translatorial signals. It seems to be living there, with this side note that the most distinctive are usually the function words. So the, and, of, I, those words that you know better than me are very much linked to the grammar rather than to just the vocabulary, right? So it's a multifaceted answer to your question, I'm afraid. But yeah, the signal lives somewhere there for sure.
Any other questions?
Yeah, I have one. If I may.
Where?
Here.
Okay.
Thank you so much for what I feel was a very suitable opening of this conference. So allow for a comment and a question. So I have this hobby horse that the qualitative reflections resides within quantitative procedures, and I felt an echo of that line of thinking in your presentation. I really appreciated that. I feel that this is a timely thing to stress. And then the question. So in one of your slides, I think I remember you foreseeing that we are moving on the path toward a discipline formation. You had something that's indicated that digital humanities would become a discipline in itself. And I was just interested in hearing if that is something that you would like. Is that something that you actually foresee, or would you rather see digital or computational procedures sort of just imbued within traditional disciplines? Yeah.
Okay,
Thank you.
Thanks a lot for that question, which is quite political, I'm afraid. I will become the professor of digital humanities here in Tartu, so for that very reason, I wouldn't mind if this discipline existed. However, I'm quite far from, messing with the list of disciplines, introducing some more, taking out some disciplines that I don't really like. This is the work to be done at the ministerial level, and in some countries, for example in Poland, there is a list of disciplines. It's like 44 plus disciplines, in which you can award your PhDs, MAs, BAs even. So it's not on the level on the university to decide. If you want to be a DH person, then you have to be either a linguist or a historian or a literary scholar or whatever. And then you might add the specialization of digital humanities in a diploma, but for most part, it needs to conform with the official list of the disciplines. So I'm not a very big fan of that. To say more, I'm a big fan of just observing how the things emerge. Back in time, no one cared whether there was still chemistry or already biology. It was just, emerging. Something was emerging, and then afterwards, some labels were put. So I'm a proponent of this kind of approach, of putting labels afterwards rather than proposing to introduce this discipline over that. But I wouldn't mind if it existed already. I'm not sure if it answers. Okay, thank you.
I think we have time for one more question if there's someone that has one. Otherwise, I actually am curious about something. So at the beginning of your talk, you talked about how it's extremely reductionist, this method. Do you foresee a future where we can use computational methods that aren't reductionist?
Ooh, okay. That's a great question. I hope I will not offend anyone here. Okay, but back in time, there was a beautiful discipline, absolutely amazing. It was alchemy. Alchemy, which was a combination of some experimental science with some philosophical formation, with some theological and hermetic and Neoplatonic thinking all together. It was a beautiful discipline, except that not very useful. And the reductionist move that happened in the 17th century, like cutting off like 90% of it and just focusing on the experimental part, was a big move forward for chemistry. Did I answer your question?
Yes, okay.
Reductionism is not a bad thing, its aspects.
Yep. Okay, thanks. Well, we're very grateful. And we have a gift of appreciation for you as well, so if we could
thank you very much.
Maciej one more time.
Thank you, I really appreciate it.
And at least those of us whose stomachs are in Eastern European time zone are starting to get hungry. So we'll stop now for lunch. What time is the next session? At 1:30? Is that correct? Yeah, exactly. So thank you all and enjoy your lunch. Hei adisu.